Sustainable design is the philosophy of designing physical objects, the built environment, and services to comply with the principles of social, economic, and ecological sustainability. Theory. The intention of sustainable design is to eliminate negative environmental impact completely through skillful, sensitive design. Manifestations of sustainable design require renewable resources, impact the environment minimally, and connect people with the natural environment. Beyond the elimination of negative environmental impact, sustainable design must create projects that are meaningful innovations that can shift behavior. A dynamic balance between economy and society, intended to generate long-term relationships between user and object, service, and finally to be respectful and mindful of the environmental and social differences. Conceptual problems. Diminishing returns. The principle that all directions of progress run out, ending with diminishing returns, is evident in the typical S-curve of the technology life cycle and in the useful life of any system as discussed in industrial ecology and life cycle assessment. Diminishing returns are the result of reaching natural limits. Common business management practice is to read diminishing returns in any direction of effort as an indication of diminishing opportunity, the potential for accelerating decline, and a signal to seek new opportunities elsewhere. Unsustainable investment. A problem arises when the limits of a resource are hard to see, so increasing investment in response to diminishing returns may seem profitable, as in the tragedy of the commons, but may lead to a collapse. This problem of increasing investment in diminishing resources has also been studied in relation to the causes of civilization collapse by Joseph Tainter among others. This natural error in investment policy contributed to the collapse of both the Roman and Mayan, among others. Relieving overstressed resources requires reducing pressure on them, not continually increasing it, whether more efficiently or not. Waste prevention. Negative effects of waste. About 80 million tons of waste in total are generated in the UK alone, for example, each year. Experience has now shown that there is no completely safe method of waste disposal. All forms of disposal have negative impacts on the environment, public health, and local economies. Landfills have contaminated drinking water. Garbage burned in incinerators has poisoned air, soil, and water. The majority of water treatment systems change the local ecology. Attempts to control or manage wastes after they are produced fail to eliminate environmental impacts. The toxic components of household products pose serious health risks and aggravate the trash problem. In the US, about 8 pounds in every ton of household garbage contains toxic materials, such as heavy metals like nickel, lead, cadmium, and mercury from batteries, and organic compounds found in pesticides and consumer products, such as air freshener sprays, nail polish, cleaners, and other products. When burned or buried, toxic materials also pose a serious threat to public health and the environment. The only way to avoid environmental harm from waste is to prevent its generation. Pollution prevention means changing the way activities are conducted and eliminating the source of the problem. It does not mean doing without, but doing differently. For example, preventing waste pollution from litter caused by disposable beverage containers does not mean doing without beverages, it just means using refillable bottles. Waste prevention strategies in planning for facilities. A comprehensive design strategy is needed for preventing generation of solid waste. A good garbage prevention strategy would require that everything brought into a facility be recycled for reuse or recycled back into the environment through biodegradation. This would mean a greater reliance on natural materials or products that are compatible with the environment. Any resource-related development is going to have two basic sources of solid waste: materials purchased and used by the facility and those brought into the facility by visitors. The following waste prevention strategies apply to both, although different approaches will be needed for implementation. Use products that minimize waste and are non-toxic. compost or anaerobically digest biodegradable wastes, reuse materials on-site or collect suitable materials for off-site recycling. Sustainable design principles. While the practical application varies among disciplines, some common principles are as follows. Low-impact materials. Choose non-toxic, sustainably produced or recycled materials which require little energy to process. Energy efficiency. Use manufacturing processes and produce products which require less energy. Emotionally durable design. Reducing consumption and waste of resources by increasing the durability of relationships between people and products through design. Design for reuse and recycling. Products, processes, and systems should be designed for performance in a commercial afterlife. Design impact measures for total carbon footprint and life cycle assessment for any resource used are increasingly required and available. Many are complex, but some give quick and accurate whole Earth estimates of impacts. One measure estimates any spending as consuming an average economic share of global energy use of 8,000 BTU per dollar and producing CO2 at the average rate of 0.57 kilograms of CO2 per dollar from those figures. Sustainable design standards and project design guides are also increasingly available and are vigorously being developed by a wide array of private organizations and individuals. There is also a large body of new methods emerging from the rapid development of what has become known as sustainability science, promoted by a wide variety of educational and governmental institutions. Biomimicry, redesigning industrial systems on biological lines, enabling the constant reuse of materials in continuous closed cycles. Service substitution, shifting the mode of consumption from personal ownership of products to provision of services which provide similar functions, e.g., from a private automobile to a car-sharing service. Such a system promotes minimal resource use per unit of consumption. Renewability. Materials should come from nearby, sustainably managed renewable sources that can be composted when their usefulness has been exhausted. Robust eco-design. Robust design principles are applied to the design of pollution sources. The physics principle that accounts for the urge to have sustainability, and for the evolutionary design in general, is the Conceptual_law. Bill of Rights for the Planet. A model of the new design principles necessary for sustainability is exemplified by the Bill of Rights for the Planet, or Hanover Principles, developed by William McDonough Architects for Expo 2000 that was held in Hanover, Germany. The Bill of Rights insist on the right of humanity and nature to coexist in a healthy, supportive, diverse, and sustainable condition. Recognize interdependence. The elements of human design interact with and depend on the natural world, with broad and diverse implications at every scale. Expand design considerations to recognizing even distant effects. Respect relationships between spirit and matter. Consider all aspects of human settlement including community, dwelling, industry, and trade in terms of existing and evolving connections between spiritual and material consciousness. Create safe objects of long-term value. Do not burden future generations with requirements for maintenance or vigilant administration of potential danger due to the careless creations of products, processes, or standards. Eliminate the concept of waste. Evaluate and optimize the full life cycle of products and processes, to approach the state of natural systems in which there is no waste. Rely on natural energy flows. Human designs should, like the living world, derive their creative forces from perpetual solar income, incorporating this energy efficiently and safely for responsible use. Understand the limitations of design. No human creation lasts forever and design does not solve all problems. Those who create and plan should practice humility in the face of nature. Treat nature as a model and mentor, not an inconvenience to be evaded or controlled. Seek constant improvement by the sharing of knowledge. Encourage direct and open communication between colleagues, patrons, manufacturers and users to link long-term sustainable considerations with ethical responsibility, and re-establish the integral relationship between natural processes and human activity. These principles were adopted by the World Congress of the International Union of Architects in June 1993 at the American Institute of Architects, Expo 93 in Chicago. Further, the AIA and UIA signed a Declaration of Interdependence for a Sustainable Future. In summary, the declaration states that today's society is degrading its environment and that the AIA, UIA, and the members are committed to placing environmental and social sustainability at the core of practices and professional responsibilities. Developing and continually improving practices, procedures, products, services, and standards for sustainable design. Educating the building industry, clients, and the general public about the importance of sustainable design. Working to change policies, regulations, and standards in government and business so that sustainable design will become a fully supported standard practice. Bringing the existing built environment up to sustainable design standards. In addition, the Interprofessional Council on Environmental Design, a coalition of architectural, landscape architectural, and engineering organizations, developed a vision statement in an attempt to foster a team approach to sustainable design. ICE states, the ethics, education and practices of art professions will be directed to shape a sustainable future. To achieve this vision we will join as a multidisciplinary partnership. These activities are an indication that the concept of sustainable design is being supported on a global and interprofessional scale, and that the ultimate goal is to become more environmentally responsive. The world needs facilities that are more energy efficient and that promote conservation and recycling of natural and economic resources. Applications of this philosophy range from the microcosm, small objects for everyday use, through to the macrocosm, buildings, cities, and the Earth's physical surface. It is a philosophy that can be applied in the fields of architecture, landscape architecture, urban design, urban planning, engineering, graphic design, industrial design, interior design, fashion design and human-computer interaction. Sustainable design is mostly a general reaction to global environmental crises, the rapid growth of economic activity and human population, depletion of natural resources, damage to ecosystems, and loss of biodiversity. In 2013, eco-architecture writer Bridget Meinhold surveyed emergency and long-term sustainable housing projects that were developed in response to these crises in her book, Urgent Architecture: 40 Sustainable Housing Solutions for a Changing World. Featured projects focus on green building, sustainable design, eco-friendly materials, affordability, material reuse, and humanitarian relief. Construction methods and materials include repurposed shipping containers, straw bale construction, sandbag homes, and floating homes. The limits of sustainable design are reducing. Whole Earth impacts are beginning to be considered because growth in goods and services is consistently outpacing gains in efficiency. As a result, the net effect of sustainable design to date has been to simply improve the efficiency of rapidly increasing impacts. The present approach, which focuses on the efficiency of delivering individual goods and services, does not solve this problem. The basic dilemmas include the increasing complexity of efficiency improvements, the difficulty of implementing new technologies in societies built around old ones, that physical impacts of delivering goods and services are not localized, but are distributed throughout the economies, and that the scale of resource use is growing and not stabilizing.